Welcome everyone to the first webinar, part of the Flex Industries Training and Education Program. This is the first webinar which will be focused on the regulatory and authorization barriers in energy flexibility. Before leaving the floor to our speakers, I just wanted to briefly show you the agenda for today's webinar. So first of all, we have a training session led by EDP, and the speaker is Antonio Ares de Matos. Then we'll have a presentation by the sister project of Flex Industries, TRINEFLEX, with the speaker Michela Mazzoccoli, and then another presentation by another sister project, FLEX4FACT, which will be led by Adriano Caprara. At the end of the webinar, we'll have also an interactive session with all of you. So at any moment during the webinar, feel free to use the Q&A section of the webinar to write any comments or questions that you have for our speakers. So I'll leave the floor to Antonio now for the first session, and let me know if you have any comments or questions anytime. Thank you.
Okay, hello everyone. I hope you can, I think you can hear me and see me. And I think I'm in control of the presentation now. So once again, good morning all. I would like to start just to give a very brief presentation about EDP, because of course we are in the Flex Industries project, but our aim also in these European projects is to meet partners, know partners, because we are always engaged in doing European projects, learning more, not only in this area of flexibility, but in other areas. So I'd like to present a group and EDP new that possibly and hopefully we can meet and join in other projects. So EDP as of today is a global company. We are present in four main geographies, four hubs. So Europe, of course, where we started, we are a Portuguese company doing business for a long time in Portugal, Spain, and Brazil. But in the last, I would say, last decade, we have been expanding a lot. And now, as you can see, we have hubs in Europe, North America, South America, and APAC. Our goals and commitments are quite ambitious. So by next year, we'll be coal-free. In 2030, we aim to be all green, and by 2040, net zero. So this is 10 years ahead of at least the European goals. And we have a strong commitment to expanding our renewable energy sources installation in the coming decade until 2030. EDP New is we are the R&D arm of EDP Innovation. So then we have this innovation umbrella, and EDP New is, let's say, the entry door. So we are doing these European projects and consultancies, and our aim is to look at new technologies, new business models, new ideas that will come up in the next 5 to 10 years. So that's why we are engaged in these three pillars. So R&D projects, mainly European ones, internal and external consultancy, and of course then we take care of the proposals. And that is the point where it's very important to have partners in different areas with different objectives, so we can engage and get the best team together. To give you a broad idea, so at the moment we are 55 people in the team. We are running 45 R&D projects. And I would highlight these 5 departments that we have that may be connected in some more interest to your companies and organizations. So the team where I am is inside this global energy management. We deal mainly, sorry, presentation just, I think it's...
Yeah, sorry. Do you have control of the presentation? Because I think I am still moving the slides. Okay, now you should have control. Okay, because before I was moving them. Okay, perfect.
Okay.
Sorry. Thank you.
Okay, no, it's
Thank
okay.
you.
It's okay. So great. So I was saying we are 55 people in the team, running 45 R&D projects at the moment and 12 consultancies. And then you have these 5 different departments as we are organized. And that is where then possibly in future contacts we can talk, because maybe you are fit to one of them more than the others. So I am inside this global energy management team, which deals mainly with flexibility and storage. Then we have other teams that are responsible, for instance, with new technologies. Some teams that are more related with the smart grids and grid development, and also client solutions, which is much more on the client side, to aim to optimize or to have smarter buildings, smarter industries. And then we have a transversal digital team. So this is we, and I use the opportunity to present myself. My name is Antonio Ajdematch. My background is in electrical engineering. I have an MBA as well, and I've been working in the energy sector for 14 years. First, I was with the transformers manufacturer, then with the Portuguese DSO, and now at EDP New. So diving now to the topic that brought us here today, which is flexibility. So I would like to structure this presentation at first instance very broadly. What is flexibility? How are the European framework, regulations, barriers? And then we will dive a bit deeper into 2 of the demonstrators of Flex Industries, just to give you a contact or an idea of what are the differences when we talk even between European countries. So flexibility, as I believe most of you know, is this ability to change rather to increase or decrease the demand or the supply of electricity. To engage this, we need, of course, or we are using different types of technologies, so smart meters to being able to understand the consumption, rather the historic consumption, or in some cases real-time consumption of the client. Energy storage, and I can actually share with you that this week I'm actually out of home because at TDP we are running our yearly innovation week where we grab people from all the geographies and we are talking about the coming challenges. And this one regarding energy storage batteries is one of the hottest topics right now. Yesterday we were all day discussing about this, how is the fit in different geographies. Of course, for today's presentation, we are talking mainly about Europe, but the challenges are globally. Our greatest deploy of battery systems is in the US, but also in APAC region, there are a lot of deployment, and we are still trying to figure out what is the best business fit for it. And continuing with the technologies, we have the demand side response, as you know, is this ability for a client or in industry, a group of clients, to make their consumption vary, and this way helping the grid, taking care of pricing conditions, and in this way being able to make the most out of the current conditions on the grid. And of course, energy flexibility is deeply connected with this transformation of the energy sector, with a lot more renewables coming to the grid, being hard at the moment to do investments on the grid as the interest rates are high. Companies try to delay as much as possible investments on the grid, so flexibility comes more and more demanding and interesting for the players. This is, of course, connected. We feel this much more, of course, in Europe, as there are these very ambitious goals that the European Union has set up. So in one hand, we have this transformation of the energy sector with a lot of wind and solar being installed on the grid. Of course, as you all know, wind and solar are not dispatchable, meaning when it's sunny it produces, when it's windy, it produces, and when it's not, it doesn't. So this brings a lot of challenges to the people and to the entities that are exploring and managing the grid. And also there are changes in energy consumption when it comes to electric vehicles. A lot now with the data centers, all the new efforts in artificial intelligence and the patterns of consumption in these types of items. And of course, as I mentioned before, these goals that until 2030, inside Europe, we are supposed to be 55% low on emissions compared with the 1990 levels, and to be net carbon neutral until 2050. And of course, most of these, it's engaged with electrifying as much as we can. So to finish this first part, just to tell you that one of the two main drivers we see as objectives to mitigate these emissions is this demand side response, in which, of course, Flex Industries is engaging a lot, and energy storage. Of course, now a lot of debate regarding technologies, which technologies to deploy, where to deploy it, if it makes sense that these battery systems are always coupled with wind farms and solar farms, or if they can be utilized as a standalone. And also in a more broader level, the interconnection of the European power system, it's something that we also see, and any guideline framework that is coming up is insisting on this point. For instance, here in Portugal and Spain, we feel a lot the connection with France that could be stronger and help a lot with some of the price fluctuations, and sometimes also to export all this power we are generating with wind and solar. But just to give you an idea of what is being tackled in the European level. And as recommendations, I also thought it was interesting to state here from the last report, what we see is that this willingness to have this more coordinated planning and operation of the energy system when it comes to interconnections, when it comes to cross-border energy transactions. It's something that should be pushed. And also at the same time, and we will see this a bit further, that it's very important that the consumers, both the industries and the residential consumers, understand that this dynamic of the market, these prices that can be lower than what they are used to pay, really reaches them, so they can understand that this demand side response, this adjustment of the consumption they have, it's also good for their pockets. That is something that we are still seeing today, that in many cases it's not happening. When it comes to flexibility, we also thought it was interesting to showcase to you once again the drivers that were behind this. So the liberalization in the European markets, in the electricity markets, decentralized energy system, renewable sources coming in, and the digitalization and the ability to process all this data opened the door or unlocked these chances to flexibility. Also, when we talk about flexibility, sometimes we are thinking a lot in the real-time flexibility. So how I can lower my consumption now and how this will benefit the grid. But when we think about flexibility, we also have to think about the different time horizons. For instance, in Portugal, as it comes to be, we are starting to have more and more dry summers. For instance, the management that is being done with the water in the hydropower, it's something that is very relevant. So the management that is being done there is not only with the electricity prices and what is going to happen, but also managing water for how do you say it in English, to water then the plantations, to the tourism that is around water, So this water management needs to be done not only on a day-to-day basis or an hour-to-hour basis, but also, let's say, managing water from winter to summer, and to, let's say, being able to regulate all of this. And of course, you understand during the day as well. Of course, in the day we have solar power, at night we don't. Also, when we talk about these battery systems or the adaptation, it's also related to this. And I believe most of you are now aware of this so-called buck curve. That is that during the midday we are starting to have a lot of solar power. So on those moments, we can store the electricity, or electricity prices go to negative values, but then at the end of the day, the price peaks. So how to manage this is also one of the challenges we are having. Also, very briefly, just wanted to tell you that the organizations inside the European system that sketch these flexibility needs and that are pushing, let's say, the roadmap in the member states are these two agencies. So the European Environmental Agency and the Agency for Cooperation of Energy Regulators. So many of the recommendations, many of the roadmaps, and let's say the checking that is being done with member states, it's coming from these two institutions. And now I would like to guide you through the barriers that we think it would be interesting to highlight. So at the moment, the adoption of flexibility has a few barriers, both in the macro level and also with the customers themselves. So I will not read or go through everything, because I believe that this presentation will be given to you by the end, will be available. But when it comes to economic barriers, of course, the understanding that to roll out significant infrastructure for flexibility, it demands a lot of investment upfront. So you have to have the ability to understand and measure the customers that you are trying to supply or to give this flexibility, and also the splitting in this economic effort usually has been done in part by governments or by the DSOs, but sometimes to unlock flexibility options, the customers themselves have to put money up front, and this is sometimes a barrier. Behavioral barriers, we see this a lot as well. That is the lack of awareness from customers, both at industrial level and at residential level, to know that this even exists, this ability to take advantage of moving prices. And we will dive a little bit after into how these markets are structured, to understand where might be the best fit for a residential customer or an industry to fit in. Of course, these barriers, they are not silos; they are connected. For instance, here on the technical barriers, we also wanted to highlight insufficient digital structures, such as the lack of smart meters. For instance, when I was working in the DSO, we did the complete rollout of smart meters for industrial clients, but for instance, the rollout of smart meters in Portugal for the residential customers is still ongoing. So if I am a customer in a small village and I want to take advantage of this type of systems, I can't, because maybe my smart meter will only come in 2025, 2026. Then only after all of that will be the structure in place to take advantage of this. Then also legal barriers. So as we will see in many countries, the possibility to enter these flexibility markets is not as easy. There is a lot of legal framework and confirmation of the type of installation that the customer has until they are able to enter these type of markets. And then the two main pillars that brought us here today, and that were in the title of the presentation. So regulatory and authorization barriers. So in many countries still today, regarding regulation, there are, let's say, minimum and maximum bounds to which a customer can enter these types of markets. Also, as we will see a bit after, the ancillary services architecture, which is something that we are seeing more and more that can be interesting, and I will dive into more detail on that a bit later. This structure for ancillary services sometimes is not remunerated, so clients are losing, let's say, an opportunity that otherwise they might have. And regarding authorizations as well, we are also being in contact with this a bit all across the world, which is to being able to meet some of the possibilities for flexibility. Government agencies or regulatory agencies, they need to approve that the installation is fit to enter the market. And we are seeing a huge backlog of processes being dealt with. For instance, just to give you a brief example, TDP, we were trying to deploy a utility scale battery in Germany. And as I understood yesterday, the estimated waiting time is between 9 and 12 months. So you understand that if you are considering an investment and you have this uncertainty at this scale, probably you are not going to enter the market. So this can also be a constraint. And just before I move forward, I would like to give you this idea, this concept. Maybe this is not the most technical term, but when I think about flexibility, I like to think of two types of flexibility, two main types. So let's say the big bulk flexibility, which is usually the selling or the buying of electricity on a spot market. Let's say a big chunk. So let's say for the next 15 minutes or for the next hour, I have this need of energy to the grid and I buy it or I sell it at that moment. And then we have what I would like to think as small or a granular flexibility, which is this one related with ancillary services, which is usually a very small amount, but that is critical for the DSOs and the TSOs to make the equilibrium to the power grid. And this more granular one is the one that enters the ancillary services, which is the slide I have next to show you. And just to one of the ideas that I would like to pass today is that this type of flexibility. So if you rather choose to enter this bulk energy one or this more granular one, can have a different business case. And this is actually what we are exploring a lot right now, is to understand if I can get more revenues from just selling bulk energy, or if it's more interesting to enter these ancillary services, or if I have a dual strategy and I actually try to play in both markets. So here you can see very briefly how the different ancillary services are when it comes to a response to an event on the grid. So FCR, AFRR, MFRR, and the RR, as we call it. And I couldn't get for all the markets, but this is a work we've been doing at TDP in the different geographies that we are present. So here you can see, for instance, that in some markets, for instance, FCR, which is this first ancillary service, in some markets it is remunerated and others it isn't. And it goes the same, so we chose the geographies as an example, but it differs, or it can differ from country to country. And this is also one of the main highlights I would like to give you, is that depending on the geography where the client is, it might be more interesting one or another. Very briefly, because I think it also needs to come down to our project. So what is expected of Flex Industries, and here we wanted to highlight the four main pillars. So as you know, Flex Industries is this project that aims to to help with the green and digital transition for industries that are typically heavyweights and that are not so easy to decarbonize and to have this type of transition. So a great effort is being on this. Of course, the presentation today is a bit more on the connection to the energy markets, but we know that much of the effort that is being done on flex industries is actually in-house to understand inside the industry itself, how can the processes be optimized, what type of internal efficiencies can be achieved, and in this way reduce emissions as we progress. Here we also want to highlight the other pillars, which is to make the people that are working in this type of industries more safe, being able to work in a safer and cleaner environment, and at the same way, and as it is one of the European roadmaps and drivers to digitalize and help with a reduction in emissions on it. Very briefly, because I think I'm running a bit out of time, but I chose here two of our demonstrators just to show you how it can be differ. So we will look at two demonstrators in Southern Europe, so Mill Oil in Greece and Swan Pharma in Italy. And just to showcase that two demonstrators south of Europe, the markets are different, the structure of the market is different, so the fit they have might not be the same from one to the other. So Mill Oil, as you know, is our demonstrator that is a producer of biofuel. They also run an electrical power plant inside the company in which, and here I chose to put some of the demo targets, not in detail, because also not sure if the audience was just going to be from inside the project or other people. But in one of the demo targets, they have increase of electricity generation by renewable sources and selling to the grid. But when we look at how the Greek electricity market is structured, we see, and this here is my fault for both of the demonstrators, I don't know when they say selling of electricity to the grid, what is the detail on this, but I'm assuming that it would be in the day-ahead market or in the intraday market. But for instance, if Mill Oil wants to look at the balancing market, there is this structure in which they can sell capacity, they can sell energy, and inside this Greek market, actually all these ancillary services are remunerated. So this could be a good business use case for Mill Oil to check if the revenues they are having right now are optimized, or if the provision of ancillary services, also to say that this can be a barrier because in some geographies there needs to be let's say, a more close connection with the DSO to understand how these services can be provided, but this is an interesting source of revenue that should be studied. So this is the Greek market. If we look now at Swan Pharma, which is our demonstrator in Italy, in the area of pharmaceuticals. So in this case, very close geography. Also here as well, Swan Pharma aims to increase flexibility from their assets. But when we look at the Italian market, the structure is different. It's, of course, is not entirely different because there are a roadmap in the European Union, but the structure itself is different. And in the case of Italy, you have this so-called local flexibility markets, which is run in a pilot basis to understand how is the behavior. And then you have the real ancillary services market in which Swan Pharma could also look at. And here, for instance, primary or FCR is not remunerated. So the business case would change in relation to the one that we saw for Mill Oil. So once again, and the main idea that we wanted to highlight here is that markets are different. The type of regulation in the market is different, and for each of the demonstrators or for the clients, it makes sense to study their own market, understand how they can participate to take the most revenue out of it. And just to finalize, so the key takeaways here is that the European energy system is changing. There will be a lot of effort on grids as we have more and more RES technologies being deployed. Storage will also be one of the key drivers in the next coming years, but also to tell you, because it's also another topic that I deal in other two projects. Hydropower storage is still the main driver of storage around the world with 95%, but battery storage will increase, and the demand side flexibility will help to delay some of the investments on the grid and to assimilate these RES technologies. Regarding our partners, the main message we wanted to pass here is that each member state has a different configuration of the electricity market. We would recommend that partners look at the ancillary services market, as we see that can be a good source of revenues and profitability, and also in these cases to understand how is the delay, how is the process of making new flexibility sources coming together in the grid, because with delay they can be a major issue. Thank you so much. I will answer questions after. If I am not completely sure of the answers, we will be in contact. I believe you'll have my email, and please feel free to reach out, and thank you for your attention.
Thank you so much, Antonio, for the presentation. I'll leave the floor now to Michela for the next presentation. You should be able to take control of the presentation and move it yourself.
Yeah, thank you.
Thank you.
Thank you, Martina. Thank you for the invitation. I'm Michela Mazzaccoli from TICAS, Italy. The TICAS is the leader of communication and dissemination in the TRINEFLEX project. The TRINEFLEX project is focusing again at the flex industries in energy flexibility, process optimization, and feedstock flexibility in energy intensive industries. So very similar to flex industries. But the activity on regulations is carried out by another partner, North from Norway, but unfortunately no one from this company was available today. That I will present their work. So in the TRINEFLEX project, one specific task is related to...
Sorry, Michela.
Yeah.
Sorry to interrupt you. I don't think you have control of the presentation, because I can still see the last slide that Antonio showed.
Okay, sorry, because I see I can move the slide.
Do you see the button? Okay, now I see the slide.
Okay,
because
okay. Sorry, but it was me. I don't know if you can give.
You have to click on the take control button up on the next to the live.
Okay.
Did you see? Okay. I see now that you have control. Thank you. Sorry for interrupting. Thank you.
No, don't worry. Now you see the right slide. It's the
yes.
Okay. So sorry. Okay, so in the TRINEFLEX, one specific task is focused on the policy framework, and its objective is to assess whether and how the European and national policy framework can support the implementation and deployment of TRINEFLEX solutions. Initially, the activities was dedicated to an overview of European national legislations, later a more in-depth study analysis related to the demo cases involved in the TRINEFLEX project will be carried out. So at the moment is an overview. We have results on an overview of the European and national legislation. One of the macro trends of the current EU policies is as you know, the decarbonization, and so making the European Union the first climate neutral continent by 2050 through European green and digital transition. where the important keywords are energy security, resilience, strategic autonomy, and industrial competitiveness. This latter also due to the increased geopolitical tension. Moreover, with the Clean Industrial Deal, the new EU industrial policy that is being developed, it seems that more attention is being paid to the industry. So these trends influence the energy flexibility adoption and implementation in the different member states, but the implementation is responsible of the member states. Also, there are the division of competencies between European Union and the member states. This division is outlined in the Treaty of the Functioning of the European Union. So this treaty establishes the energy internal market environment is regulated as a shared competences, so it's regulated by exclusively the European Union. So the European Union have more ability to propose a regulation to regulate these topics. While the EU only may support, coordinate, supplement member state action in industrial sector. So therefore, the European Union doesn't have the power to create binding acts, mandating the member state to align their law regulation. So the consequence is that, for example, regarding the Renewable Energy Directive and the Energy Efficiency Directive that include the goals from the European related to energy, the increasing of energy, renewable energy, also the improve on energy efficiency, include this goal of the European, but it's up to member state to find a proper solution to achieve this goal, how to under the implementation of this regulation in the different national administration. So as Antonio said before, one of the main challenges is the different regulation, the different market in different countries. So different plants and company and factories in the same company, but they are in different countries, maybe facing different regulations and different laws and barriers. So it's very important. One of the key finds that we found is it's very important, the coordination and cooperation between different regulatory bodies. Now we go more in depth to the national law, in particular the governance of the energy union, that is a EU regulation part of the clean energy for all European policy packages from 2015, requires that member states establish the national energy and climate plans. And so the studies is related on Greece, especially Greece, Italy, and Spain, because there are the countries where our demo cases are located. So these national energy and climate plans are the tool to forces the member state to came up with some potential solution to improve the energy flexibility, to reduce energy consumption, and so on. The final updated plans were recorded by 2024, in June 2024. Italy and Spain have already presented this plan. Greece has not, so the information here are based on the updated plan presented last year in 2023. All countries indicated support for EU climate ambitions and policies, but also recognize that it's very important to maintain jobs, to maintain a competitive market. So they recognize that the energy transition is a very complex process. In addition, the three countries demonstrate also different prioritization. For example, Greece is dependent on EU funding for energy transition, and one focuses on the improvement on energy efficiency in all industrial sector by means of energy audits, promotion of energy saving programs, and also energy efficiency obligation schemes. While Italy is focused more on buildings, mainly on buildings, so whereas there are little concrete policies for industry. One of the measures that Italy uses is put already in place is the tax credits to stimulate investment in innovation and sustainability. Regarding Spain, one of the measures that are decided is the improvement in technology and process management system in industry energy intensive, with the aim of support and facilitate the penetration of energy saving techniques in this kind of industries. Also, put some measure for the promotion of energy performance contracts or training of professionals. So one focus is also on training and energy audit. So to conclude, as I said at the beginning, the regulatory and policies frameworks are very different in different countries, but also for different sectors. In TRINEFLEX, we have 5 demo cases of 5 industries and 4 sectors: glass, aluminium, copper, and wastewater treatment, and each sector are distinct needs and prerequisites, and so the one size fits all policy response may not be effective in this scenario. It is necessary the policies across different levels has to be seen and studied in an holistic manner, prepared and proposed in an holistic manner. So it's very important to find the right balance between policies and regulation that obviously has to push the industry to make the changes they needed for the energy transition. But in the meantime, it's necessary the balance with this kind of policy, more flexible scenarios, so more flexible regulatory frameworks that can allow the different industries, the different sectors to adapt according to their respective needs. So, as also Antonio said, it's necessary to for each industry and each sectors to analyze the markets, the regulatory frameworks, but also it's necessary that the regulatory framework is more consistent and more uniform at the European level. Thank you for your attention.
Thank you so much, Michela. Okay, so we'll have the last session now with Adriano. You can take control of the presentation.
Okay, yeah. Can you hear me?
Yes, I don't see if you took control of the presentation.
I believe I have control of the slides.
Okay, perfect.
I mean, yeah, I think I do. Okay, so
Try changing slide. Sorry, just a second.
Did you see it?
No, you have to click on the
Okay.
take control, but okay, now you have it. Thank you so
Okay,
much.
now I do. Sorry.
Go on.
Yeah. So I would like to, as I said, my name is Adriano Caprara. I'm a PhD researcher at SITSEA UPC, which is a research group of the Electrical Engineering Department of the Polytechnic University of Barcelona. And for the past 2.5 years, I've been working on the FLEX4FACT project, and I'm here to share with you our experiences in navigating regulatory barriers as means to activating industrial flexibility. A bit of an overview on the project. It's quite a large European project with 23 partners across Europe, 42 months of duration, and 18 millions in funding from Horizon 2020. Going a bit through an overview of the different aspects of the projects. We are aiming at enabling industrial flexibility through different layers of digitalizations applied to our 5 industrial projects. And we begin from the technical analysis of each of the pilot sites and moving on from the physical layer to the digital layer with the creation of digital twins, which allows us to create dynamic representations of the manufacturing processes while also taking care of the cybersecurity aspect. And finally, once we have control and knowledge and the monitoring of our industrial processes, we can optimize the electricity consumption, the storage, and the electricity generation when present in order to optimize flexibility offers to the markets. Now, focusing on barriers to industrial flexibility, similar findings to what Antonio has already covered in his presentation, but going even more specifically to industrial cases, I believe that regulatory barriers are the first ones, which then cause, as a consequence, technical and economic barriers, which are just as important. So, starting from regulatory barriers, from our findings, there are limited specific schemes for industrial participation, which lead to difficult market access, constrained by response times and bid requirements. And this is also particularly difficult for the marketing of flexibility when we consider that in European countries, industrial electricity consumptions amounts to more than 30% of the national electricity demand. This leads to technical barriers because, of course, it is not always possible to adapt the manufacturing processes to the size and requirements of the flexibility bids that are currently in place in national markets, and overall the biggest limiting factor, which is the economic aspect. That means that marketing of flexibility is only possible when the cost-benefit ratio is favorable for our pilot sites. So, what markets have we tried to study? Well, we tried to cover the ones that are more in common between several European states, and that's why I also have a small introduction about balancing services. And specifically, we decided to focus on 2 of the balancing services to restore balance, which are the markets that we are expected to see the largest growth in due to the integration of renewable energies. And these are the automatic frequency restoration reserves and the manual frequency restoration reserves. The automatic frequency restoration reserves is generally directly managed with the TSO with automatic signals to pre-qualified assets. Whereas the manual activation reserve usually has less stringent qualifying qualities to participate, but can provide larger and longer support for frequency restoration. Why are we focusing on the differences on these markets? It's because the bit size requirements, the validity periods, and the responsiveness can be a critical threshold and barrier for industrial flexibility participation. In this table, I have summarized most of the parameters about these markets, and I can tell you that automatic frequency restoration reserves with current circumstances requires for the TSO to assume direct control of the loads and the manufacturing process of a factory, for example, by shutting down an industrial oven. And thus we have found, iterating over also with the pilot projects, that it is currently an unattractive setting for industrial flexibilities. We have also experienced, studying the various markets, that there have been several delays in manual frequency restoration reserve flexibility trading, and this is also true for the MARI platform, which is an European initiative to cross-border trading of flexibility, but also for the Picasso, which is a similar platform for automatic frequency restoration reserves. And I believe this also reflects what both Michela and Antonio mentioned so far. So as a barrier, we also experience complexities in cross-border coordination and large variations in national market designs. So how do we try to solve this with our framework? Well, we have developed two platforms to accommodate both the needs of the market as well as the needs and requirements of the production processes. So we have on the left in green our scheduling platform, which takes care of the management of the specific industrial processes of the companies, which must be taken into account when marketing flexibility, first through an internal optimization of industrial energy cluster or an industrial energy community that we have developed, and then aggregating flexibilities among the various pilot sites to access external market optimization. Why are we doing this? We are doing this because we are also unlocking new flexibility products by enabling internal trading of flexibility within our industrial energy community. And then by aggregating the possible schedule changes of our factories in the pilot sites, we can then overcome bit size requirements in the case of smaller industries with limited flexibility capabilities. Now, I would like to show an example of a success story of one of the pilot sites that we uncovered, which was first the adaptation of the production process to provide flexibility by changing our baseline consumption to flex offer 1, as you can see in our graphic, by stopping abruptly the furnaces, thus gaining a flexibility of approximately 100 megawatt or even more, 140 megawatts, which allowed us to create an extremely large flexibility offers, however, at a reasonably high cost of 187 euros per megawatt hour. The value of this offer, of course, is that it has a shorter activation period. However, abruptly interrupting the production process is something that can lead to negative outcomes as well. Then, by creating our internal energy community, we were able to outline without having to interrupt the production process, and also including at the end of the day the possibility of recovering the lost production, daily flexibility with notice of 24 hours before activation, which allowed the plant operator to directly shift the consumption pattern of the industrial site, offering 76 megawatt hours at almost or 1/4 of the price of the previous offers. So we enabled an additional amount of flexibility by developing our industrial energy community, which can be offered at a lower price. So in conclusion, I would like to say that we experience similar barriers to the one identified by Antonio and Michela, which means that balancing services regulations can be strict to fully integrate industrial flexibility without compromising too much the production process. We also experience difficulties in finding access to current schemes for AFRR, as the cost-benefits ratio is key for industrial flexibility progress. But on a positive side, we experience the key role of aggregators, which can set up independent internal cluster markets to unlock new flexibility products, such as the one that I have just explained, which is the daily flexibility. Thank you very much for your attention.
Thank you so much, Adriano. I think that we can now go on with the Q&A session. If you have any questions, please write them in the Q&A section of the webinar, and we'll make sure to answer to all of them. I'm just bringing everyone on screen so you can see us. Let's just wait a few minutes to see if anyone wants to ask something. Okay, I don't see any questions coming in. If you maybe want to think about it in the next few minutes, we can start closing the webinar, and if you cannot share any questions or any comments, you can always contact us by email, so in any moment you can reach out to us. But either way, I just wanted to thank you all for your time, and I remind you all that this webinar was registered, recorded, so you will be able to watch it back whenever you want. I think it's going to be uploaded on our social medias, and also we will provide the slides to you all, so you can look through them whenever you want. Okay. I think we can close. I thank you all so much to have attended this meeting, and also to our presenters, and let's keep in contact. Bye bye, everyone.